So previous class, we discussed about the in previous video, we discussed about the proof by contraposition. So in this video, we discuss about the Vespers and trivial proof. So, what is meant by Vespers proof? Okay. So we quickly prove that a conditional statement P implies Q is true when we know that P is false, because P implies Q must be true when P is false. Okay, so before going to discuss about this statement, just write the to say about. Okay, so P implies Q. Okay, just go through the truth table of P implies Q. So what's the truth table of P implies Q? It's true, and false, false, true, false, true, false. So P implies Q means true, then it will be true. True, false, it will be false. And false, true means it's true. And false means true. Okay, so this is the truth table. Okay, and the condition here we have to true. Here the condition is when we know that P is false. Okay, so P is false is these two statements. When P is false, because P implies Q must be true when P is false. Okay, and P implies Q will be true. Okay, so when the P is false, the P implies Q is true. So this condition should have to prove in this statement. So constantly we can show that P is false when then we have a proof called backwards proof. So backwards proof when it happens in backwards proof, so it have to show P is false. Then we have a proof called backwards proof of the condition statement P implies Q. So, condition വരുമ്പോഴാണ് നമ്മുടെ സ്റ്റേറ്റ്മെന്റ് P false എന്നുള്ള ഒരു കണ്ടീഷൻ വരുമ്പോഴാണ് ബാക്ക്വേർഡ് പ്രൂഫ് നമ്മൾ പ്രൂവ് ചെയ്യേണ്ടത്. So, problem related to backwards proof. Show that the proposition P of 0 is true, where P of n is P if n greater than 1, then n square greater than n, and the domain consists of all the integers. Okay, so note that what we have to show is the proposition P of 0 is true. Okay, P of 0 true ആണെന്നാണ് നമ്മൾ കാണിക്കുന്നത്. So where P of n is, P of n means P of n is P of n എന്താണ്? If n is greater than 1. Okay, n is greater than 1, then n square is greater than n. So, okay, so using the P of 0, using that, we have to show that P of 0 is true. So, P of 0, so just replace n with the 0, so we got it as, so our assumption is that hypothesis is 0 is greater than 1, 0 greater than 1 is false. Okay, because backwards proof നമ്മൾ പറഞ്ഞിട്ടുണ്ട് P false ആണ്. So the P is 0 is, so our hypothesis is 0 is greater than 1 is false. So this tells automatically that 0 square is greater than 0. Is 0 square is greater than 0? No, it's false. So automatically P of 0 is, if P is 0, sorry, if P is false, then P of 0 will be true. So this is automatically true. Okay, so P false means then P implies Q will be true. So condition, the fact that the conclusion of the statement 0 square is greater than 0 is false. This will be false. This statement will be false statement. Statement will be false statement. Is irrelevant to the truth table of the conditional statement, because the conditional statement with a false hypothesis is guaranteed to be true. Okay, this is a false hypothesis. So the theory we say is that if P is false, then if P is false, because P implies Q must be true when P is false. So we prove that P of 0 is, hence we prove that P of 0 is true. So next one is trivial proof. we quickly prove a conditional statement P implies Q if we know that conclusion Q is true. Okay, so it will happen when these two cases. If Q is true, okay, so Q true on the cases on a case, then P of Q will be also true. Okay, so Q is true. When Q is true, show that by showing that Q is true, it follows that P implies Q must also be true. The proof of P implies Q that uses the fact that. So it will use the fact that the Q is true is called trivial proof. Okay. So the P implies Q will be true when it uses the fact that Q is true. Q true ആണെന്നുള്ള fact use ചെയ്ത് P implies Q true ആണെന്നുള്ളത് നമ്മൾ find out ചെയ്യണം. So that is called trivial proof. We have to show that. So that is called trivial proof. So let P be P of n be if A and B are positive integers with the A is greater than or equal to B, then A square so the A raised to n is A square. Okay. So our P of n. So what is our P of n is if A greater than or equal to B, so then A square, sorry, A raised to n. Sorry, not A square, A raised to n is greater than or equal to B raised to n, where the domain consists of all the non-negative integers. So show that P of 0 is true. Have to show that P of 3 is true or false. Okay. So it is true എന്നുള്ളതാണ് നമുക്ക് prove ചെയ്യേണ്ടത്. So P of n is given as A raised to n is greater than or equal to B raised to n. So just replace what I have to show is P of 0. So it replace the n with the 0. So what you got it is A raised to 0 is greater than or equal to B raised to 0. Just replace the n with the 0. Here we just replace the n with the replace the n with 0. So this is the Q. So this will be the Q, and just try to show that if P is true, then the conclusion will be true. So just replace the 0 with the 0 with n, and what you got it as A raised to 0 is 1. 1 is greater than or equal to, again B raised to 0 is 1. So 1 is greater than or equal to 1. The condition is true. So it says that P of 0 is true. Okay. So where condition is P of 0 is true. Hence we proved that. This is an example of trivial proof. Not that the hypothesis, which is a statement A greater than or equal to 0, which was not needed for this proof. Okay. So hence we prove that this is true. And the next topic is proof by contradiction. So what is meant by contradiction? Contradiction means negation of a statement. So the proof by contradiction is a logical technique used to prove a statement by assuming the opposite of the statement. That means negation of a statement to be true, and then showing that assumption leads to contradiction. So the what you have to do is this when the statement is taken, the negation of the statement is shown to be true. So accordingly, then we can show that the assumption leads to a contradiction. So the contradiction indicates that negation of the original statements. What is my contradiction? So that is given in the statement. So contradiction means negation of the original statement is false. Okay. So the original statement must be true. And this, by proving the contradiction, what will happen is the negation of the original statement is false. Okay. If you got it as if the negation ഒരു സ്റ്റേറ്റ്മെന്റ് എടുത്തു, ആ സ്റ്റേറ്റ്മെന്റ് നെഗേഷൻ ഓപ്പോസിറ്റ് സ്റ്റേറ്റ്മെന്റ് വെച്ച് നമ്മൾ സ്റ്റാർട്ട് ചെയ്ത് പോയി by applying some rules and rules of inferences. If it is got it as false, അത് false ആയിട്ട് കിട്ടിക്കഴിഞ്ഞാൽ, so that means there is a contradiction. ആദ്യം പറഞ്ഞതും ഇതും തമ്മിൽ കോൺട്രഡിക്റ്റഡ് ആയി. So that means then we can say, it simply says the original statement, starting with the original statement is true. എന്നുള്ളതായിരിക്കും നമുക്ക് പ്രൂവ് ചെയ്യാൻ പറ്റും. So because a proof by contradiction does not prove a result directly, it's another type of indirect proof. Okay, so before the previous videos, just explained about indirect proof. What is my indirect proof? And the two types of indirect proof is first one is proof by contraposition, and second one is proof by contradiction. So the proof by contradiction is explained here. Okay. So what you have to do, the steps to again, and this says that what is steps to do the proof by contradiction is we just take the negation of the original statement and we try to prove that it is false. If it is false, then we can simply say that the original statement is true. Okay. So let me take an example. First, go through the problem. First problem is show that at least 4 of any 22 days must fall on the same day of the week. Okay. So at least 4 of any 22 days, okay, must fall on the same week of the same day of the week. So here the proposition is at least of 22 chosen for days falls on the same week of the same day of the week. So this is our statement. So in the proof by contradiction, what we have to do is just take the opposite. So negation of the statement. We have to start from the negation of the statement. So what is negation of the statement? Suppose the negation of P is true. So that means at least. At least means what? At least means minimum. We have to show that minimum 3 days or not less than 3 days. So minimum 4 of the 22 days chosen days fall on the same day of the week. Okay. So that is our assumption. So the negation of that. So a negation of at least means at most. So at most and at least means minimum. So we have to take the negation. Then we got it as at most. That means maximum. So at most means maximum. So at most of the, so that is written here. At most 3 of 22 days falls on the same day of this week. So in order to prove that this is true, in order to prove that this is true or false, then we have to take, there are 7 days in a week. Okay. So we know that there's 7 days in a week. So and each can occur at most 3 times. So 7 days in a week, and this maybe happens at most 3. So here the question our assumption is 3 days. So 7 week in a days and at most 3 days. Okay, 3 times it may happen. So 7 into 3, that is 21. So maximum days we can distribute for under the assumption is 7 into 3. So 7 into 3, so that is 21. So this means that we can distribute at most 21 days. 21 days and distribute at most. So that is maximum 21 days without any day of occurring 4 or more times. So this it will contradict. So however we are given 22 days. So what is we are given is 22 days. At most 3 of the 22 days falls there. But we cannot prove that it may happen on 22 days. It's only happened to 21 days only. So we can distribute only 21 days under the assumption, and there is at least one more day to be happen one placed on the 7 weeks. So we can simply say that this is contradiction. Okay. So 21 days we can distribute only 21 days in distribute method. Question contradiction assumption 22 days distribute. So it will false. So that means the negation of the original statement is false. That means the original statement is true. So that, okay, so we know that P is true. We have proved that at least. So we can simply say that this is false. This negation of P is false and the original statement P is true. Okay. So this is the proof by contradiction. And going to the next problem. So next problem is that prove that square root of 2. Okay, square root of 2 is irrational by giving a proof by contradiction. Okay, so what you have to do is, okay, what you have to prove that square root of 2 is irrational number. Okay, so negation, we have to, first of all, what we have to take is we have to negate the statement. Okay, so negate the statement means Okay, first in the proof by contradiction, first we have to do the negate the statement. So negate the statement is that root 2 is a rational number. Okay, so the negation of this statement is root 2 is rational number. So they assume that root 2 is rational number. Okay, this means that root 2 can be written as a fraction of two numbers. So that means root 2 is a rational number means what we can return as fraction of two integers a by b. So root 2. So we can write as because of root 2 is a rational number, we can write as root 2 is equal to a divided by b. It's a fraction of two numbers. Okay, rational number means it's a fraction of two numbers. So what you have to do is just squaring the both sides. Okay, so squaring the both sides, what do we record it as? This root 2 will becomes 2. 2 is equal to a square by b square. Okay, a square by b square. Then a square is equal to, okay, just multiply it. So a square is equal to, just multiply that. Then a square is equal to 2 into b square. So by the definition of an integer number, it follows that a square is an even. Okay, a square is an even number. Okay, so it is not a rational number. Okay, so we cannot prove by the statement that, okay, sorry, a square is an even number. So we can just write it as, okay, here 2ab. By definition, it says that by the definition of integer number says that a square is an even number. So a square is an even number, so that we can write as a square is equal to 2c square. So 2c. So a square means 4. We can replace a square by 4c square is equal to 2b square. So dividing by the two, both equations by 2, both sides by 2, dividing both sides by 2, we got this 2c square is equal to b square. So by the definition of even number, we can also say that b square is also an even number. So again, using the fact that if square of an even integer is even, then the integer itself must be even. So we conclude that b must be an even number. So it is not a rational number. So we can simply prove that it's not a rational number. So it's an irrational number. So by the proof by contradiction, simply prove the square root of 2 is a rational number. Okay. So an irrational number is that it cannot be expressed as a ratio of two integers. So what is an irrational number? So that is explained here. That is cannot be expressed as a ratio of two integers. But here we can express as a ratio of two integers by the proof. So it is a contradiction. The contradiction I. So the root we can simply say that root 2 is irrational number. And then another example means another problem. Give a proof by contradiction of theorem. If 3n plus 2 is odd, then n is odd. Okay. So our question is, if 3n plus 2 is odd, then n is odd. So we can take this as P implies Q. So what is meant by P implies Q is, for going to the expression, just simply says how to negate this statement. Here we have two statements. If 3n plus 2, so that is P. Then, implies means then, n is odd. Okay, so we got it as simply by the theorem, P implies Q is P or Q. P implies Q means by the statement, we know that by the theorem, P implies Q means negation of P or Q. So what we have to do is we have to simply negate the statement. Okay, so negation of the statement we have to take in order to prove the proof by contradiction. what you have to do is negate the statement. So first of all, you have to negate the statement. So just negation is applied to this here. Okay, so what do you got? Just negation of P and negation of Q. Okay, so we can just negation and negation cancel, and what do we got it as? P and negation of Q. So this way, how we negate the P implies Q. Okay, P implies Q നെ എങ്ങനെയാണ് നമ്മൾ നെഗേറ്റ് ചെയ്യേണ്ടതെന്ന് വെച്ചിട്ടുണ്ടെങ്കിൽ ഇങ്ങനെ വേണം നമുക്ക് നെഗേറ്റ് ചെയ്യാൻ ഈ ഒരു സ്റ്റേറ്റ്മെന്റ് അനുസരിച്ച്. മറ്റോടത്തൊക്കെ സിംഗിൾ സ്റ്റേറ്റ്മെന്റ് ആയിരുന്നു, അതുകൊണ്ട് ഇത് യൂസ് ചെയ്യേണ്ട ആവശ്യമില്ല. പക്ഷെ ഇവിടെ നമുക്ക് ശരിക്കും P implies Q എന്നുള്ള അതേ മോഡലിൽ തന്നെയാണ് നമുക്ക് സ്റ്റേറ്റ്മെന്റ് തന്നിരിക്കുന്നത്. So what you have to do is you have to simply negate. So this is in this way we have to negate the P implies Q. So P and negation of Q. Okay. So ഈ ഒരു രീതിയിൽ വേണം നമ്മൾ നെഗേറ്റ് ചെയ്യാനായിട്ട്. First we have to simplify, modify the statement. If P implies Q, then it can be written as negation of P or Q. Then negate the statement. Okay, negate the statement. We got it as P and negation of Q. So, so in this way, so we have P is 3n plus 2 is order. So we can take it as 3n plus 2 is odd. And then what to do is and negation of Q. So negation of Q means n is order. So negation of Q is n is odd, P is 3n plus 2 is odd. Okay. So P is P n plus 3n plus 2 is odd, and negation of Q means n is even. N is even. Okay. So what you have to do is, because n is not odd, we know that it is even. N is even, that the integer such that n is n even ആയതുകൊണ്ട് നമുക്ക് എന്തെടുക്കാം, n is equal to 2k എന്ന് നമുക്ക് പറയാൻ പറ്റും. Okay. If a number is even, it should be a multiplier of 2. So n is even, then apply to P. So that is 3n. N means 3 into 2k. 3 into 2k plus 2. Okay. So apply to the statement. We got it as 3 into 2k plus 2. So that is 6k plus 2. So we got it as simply take 2 outside. So that is 3k plus 1. Just take this symbol. If S is equal to 3k plus 1, then we can rewrite as 2 into S. Okay, S number 3k plus 1 എന്ന് പറഞ്ഞു എടുക്കുകയാണെങ്കിൽ we can write it as 2 into S. So that means it's an even number. Okay. നമ്മൾ ഇവിടുന്ന് സ്റ്റാർട്ട് ചെയ്തു 3n plus 2 is an odd വെച്ച് സ്റ്റാർട്ട് ചെയ്തു, but we got it as 3n plus 2 is even. So our assumption is contradict. Okay, so again we leads to a contradiction. So therefore the assumption is false and n must be odd. Okay. And hence we prove that if 3n plus 2 is odd, then n must be odd. Okay, so here we can only prove that either odd, even ആണ് നമ്മൾ odd ആണെന്ന് പറഞ്ഞു തുടങ്ങി, but we got it as this is an even number. So again contradiction will be happen. So thus we proved that if 3n plus 2 is odd, then n is odd. Okay, so that's all about this video. Thank you so much. And if you have any query, please DM. Okay, thank you.